So I have a faculty affiliate appointment with Colorado State University, but I also work as a contractor. I started in March with Bayer's Western Stewardship and Development team. So today I'm going to be focusing on some work that I actually started as a graduate student and postdoc at Colorado State, and I'm now continuing to work with them as that affiliate position in conjunction with Boulder County. And so this is focusing on this pollinator habitat idea. So we've heard a lot about the impacts of invasive annual grasses to our Western ecosystems. And so today I want to focus on how we're reversing course on these impacts and really achieving restoration of these ecosystems, and then the benefits we're seeing as a result of removing invasive annual grasses from these systems. So I just want to jump right into pollinators and pollination, and so I'm going to focus a lot on that in this presentation. And so we've heard a lot about pollinators recently in the news in the last few years. And so why do we focus so much on them? Well, pollinators are really important. About 75% of our plant species rely on insect pollination for reproduction to produce seed. And so pollinators really provide a critical service to our ecosystems in terms of our native plant species. And so that's why it's really important to focus on their habitat and the degradation of their habitat and improving that. I also want to point out, because a lot of times we think about pollinators, we think about bees, but there's a lot more than just bees that are considered pollinators. And so we have things like moths and butterflies, beetles, wasps, flies, bats, birds. So several categories of native pollinators that exist in our systems. So a lot of the focus in the media has been on declines in honeybees. And so those are actually not native to North America, but they are critical for our crop production. But recently, native bees and other native pollinators have become a growing part of that discussion because they face declines as well. And so what's causing these declines? We can't really pinpoint one factor here. It's really a myriad of several things that are causing declines in both native pollinators and honeybees, but things like more infrastructure and habitat loss due to that, habitat loss due to the row cropping increases, health and disease issues, and then what we'll be focusing on today, and which I think a lot of people forget, is the impacts of pollinators from invasive annual plants or invasive plants, especially those invasive annual grasses that really provide no habitat to pollinators whatsoever. And so this is a project we started and really led by Boulder County Weed District, Jim Sebastian and Steve Sauer there, looking at some endangered ecosystems across Colorado's Front Range. And so this is a map showing Boulder County and some of our critical habitat areas. So in the green, we have outstanding biodiversity significance. So this is considered on a global scale irreplaceable ecosystems. And then in the pink here, we have very high biodiversity significance, so considered nearly irreplaceable on a global scale. And so you'll see that Boulder County has several of these highly biodiverse areas. They're all being threatened by, or many are being threatened by invasive annual grasses. And so we had 13 sites across two of these categories where large applications of Rejuvera were made to rid the area of invasive annual grasses. And so we wanted to look at the impacts to pollinators in those areas from the removal of those annual grasses. And so this is what some of the sites looked like from the 13 sites. The before, you can see really a sea of annual grasses there, hardly any native species you can pick out. And then after, and these are not photoshopped, these are from the sites, a little bit different angle, but the best I could match up. This is the flowering forb response that you're seeing come back into the site simply by removing invasive annual grasses from the system. And so with that, you can assume that you're dramatically increasing pollinator habitat because the flowering forbs that are coming back into that system. But we wanted to quantitatively assess that and see what does this mean for pollinators. So what we did was we took those 13 large-scale treatments and paired them with an untreated plot at the same site. We did assessments which occurred 1 to 3 seasons after the Rejuver application was made. We did flower number counts, canopy cover estimates of those native and weed species, and then also took litter and perennial grass biomass. So to start off, what did we find? Just to look in terms of richness, so the number of plant species we're finding at these sites, not looking at the density, just the number. We look at the untreated there at the top. We're averaged across 13 locations, seeing just over 50 species. We have them broken down here by forbs, shrubs, warm season, cool season grasses, annual forbs, and rare species. So we're going from just over 50 species to over 65 species across the 13 locations in the Rejuver treatment. So a pretty dramatic increase in just species richness alone, but I want to point out a few categories here. And we've already had some questions today on the webinar asking about this. So we actually saw 150% increase in annual forb richness. So this is just the annual forb species we're seeing come back into these sites. And so with the treatment, we're seeing more annual forbs. So we often question if we're impacting those 4 annual forbs with this treatment. But this tells us that the annual grasses are impacting those annual forbs, those native annual forbs more. So we're seeing them return after that treatment. And then we also saw a 2.5 times increase in rare or endangered species, what's considered rare and endangered in this county. So more of these species coming back in to that treated area simply because they were being so suppressed by those invasive annual grasses. So here's just a look at one of those sites. This is Rabbit Mountain, where we observed 96 different species in the treated area compared to 76 species in the untreated. So a huge difference in species richness, species coming back into the site. So I talked about flower number, and that's what's really going to be critical to the pollinators because it's directly related to an increase in available pollinator resources. And so you'll see the figure on the left here, we're looking at the number of flowers per plant. So what we did was we looked at 10 plants per species, counted the number of flowers on the treated and untreated side and compared. And so the gray bar is the untreated and the blue bar is the Rejuver application. You can see that blue bar is higher for every species on that graph. And in fact, for all 26 species we were able to evaluate this way, we saw increases in number of flowers per plant. Here's just another example. Blanket flower went from 2 flowers per plant to 8 flowers per plant. Indian breadroot, 2 flowers per plant to 4 flowers per plant with the treatment. And I talked about those annual and rare or endangered species, so I wanted to point out more of that. So when we look at that top table, the blue is native annual species and the yellow is rare or endangered species. And this is the mean flower density over 15 square meters. And so when you look here at the check, you see, get my laser, hardly anything really flowering in 15 square meters, just maybe some pony bee balm there, but not a lot going on. And then what's really impressive is when you look over here at the Rejuver treatment and the number of flowers in that 15 square meter flowering. So you can just assume that the habitat you're creating for pollinators is much improved with this treatment. We look down here, we average the number of flowers per plant over the native annuals. So you can see increases there, and then rare and endangered, almost nothing was even documented that was flowering that was rare and endangered in the treated or untreated area. But with our treatment, we see an average of 11 flowers per plant on those rare and endangered species. So huge improvement to these habitats with just an application that takes away the invasive annual grass. And then lastly, we also saw an increased cover of rare and annual species. So you can see we went from about 1% rare species to 4%. And then we had a huge jump in annual species as well, which is really exciting to see those annual species start to come back into the site. So for pollinators, what does this mean? Well, habitat diversity really facilitates bee or other pollinator diversity. And so now we've gone from a site that struggled to even have flower production, and you maybe have some of those hardier native forbs, and now we've opened that up. We have more diverse forb set where we have early, mid-season, late-season bloomers, a lot more things for pollinators to take advantage of. We're continuing this project looking at actually capturing pollinator numbers. And so we are finding just from initial observations that we are seeing increases in pollinator visitation in treated areas as well, but more to come on that at a future time. So lastly, I just want to end talking about the wildfire and actually how we can reverse course on some of this or the wildfire impacts in the West. And so we've had some great talks on or pictures shown already on the devastation these wildfires can have on these Western landscapes. And so now we really have an option to eliminate those fine fuels in these sites. And so you can see here on the right where you have cheatgrass, no cheatgrass treatment, that fine fuel accumulation in the brown here. So carry a fire really easily through this area. Where left an application of Rejuvra, that fine fuel has naturally degraded and rather quickly, which I'll show you on the next slide. And so it'd be a lot harder for a fire to carry through here with that grass that has a lot more moisture and some, spacing in between. So this data we looked at biomass collections across 7 sites in Colorado in terms of cheatgrass litter, which is our fine fuel here. And we went from about 900 pounds per acre of litter to less than 100 pounds per acre. So about a 95% degradation, and that occurred in 10 months after treatment, which is pretty impressive. But what's more impressive is if you look over here at the perennial grass, we saw an 8 times increase in perennial grass biomass in that same time frame. So what we're doing is we're replacing that cheatgrass with perennial biomass at that area, and so we're really reducing the risk of fire by removing that fine fuel from the system. And these are sites that have a remnant population of native grasses or perennial grasses there, so I just want to point that out. So lastly, I just want to end on this work being done by a PhD student at Colorado State University, Jake Korkamp. And he worked on some aerial application plots in Pinedale, Wyoming. And so these are the plots that went out. There's 4 applications done of Rejuvra at 5 ounces in September of 2016. And I'm not going to focus on his data actually, but an unexpected event that occurred last year, which is a fire that actually burned through the site. And so you can see it kind of stopped here, but it burned all around this area. This picture was taken late in the season, so it's hard to see, but this plot 3 or treatment 3 and plot 2 actually did not burn in the fire. And so we investigated a little bit more into that. And we see the picture here, you see the burn coming up to the plot. This is plot 3 again. And you can see those intact perennial grasses, shrubs here. The cheatgrass has been removed from this area and wasn't able to fuel that fire. And you can see the burn around here where it was not treated. And we look at NDVI images, you see more grass in these plots actually, and then this yellow is going to be the cheatgrass kind of areas. And so when that fire came through, there was more moisture in this area to kind of prevent the spread of that fire. This is a grove of trees over here, so that's kind of in relation to that. But you can see plot 3 really had a lot of green perennial grasses at the time. And so here's a close-up look of that plot 3, 2 months before the fire occurred when stuff was still green. You can see there's the elimination of fine fuels through here. You have space between your perennial grasses. Things are healthy. There's moisture in the grass. So a fire would have a lot harder time carrying through this area. And so Jake recently wrote a research brief that was published through Southern Rockies Fire Science Network. So if you want to read more about his study, you can actually access it at southernrockiesfirescience.org. So with that, I'd like to thank you and pass it on to Noe Marymore.